This year, the school play is Frankenstein. It's the day of the dress rehearsal. Mad scientist Victor Frankenstein is in his laboratory, mixing up some potions to make the dead come to life. It's alive! Watching this play, science looks like a guessing game where success is based on luck. In a real laboratory, scientists can't leave these things to chance. They follow a process called scientific investigation. What is scientific investigation? Scientific investigation is an organized process scientists follow to find answers to all sorts of different questions. There are two main types of scientific investigation: experimental investigation and observational investigation. Frankenstein's monster was the result of a chaotic experimental investigation. Dr. Victor Frankenstein experimented with all sorts of different methods to test out whether it was possible to make the dead come alive. Of course, in a real lab, there are rarely villagers with torches and pitchforks watching outside the gate. Some problems cannot be answered by setting up a controlled experiment to test a hypothesis. For these problems, scientists must watch or observe and then make conclusions based on these observations. What are some examples of scientific questions that could only be answered by observing? It's involving animal behavior in the wild, or the movement of objects in the solar system can only be investigated through careful observation. These scientific investigations are called observational investigations. Looks like mad scientist Victor Frankenstein is close to his breakthrough. Good thing he works alone in a castle, because his laboratory does not look at all safe. Can you spot 5 safety violations in this lab? Whenever you're handling any dangerous or flammable chemicals, safety glasses and gloves always need to be worn. Equipment should only be used for the purpose it is intended for. That means no rigging up a toaster to provide the electric current, Dr. Frankenstein. Food and drink are never allowed in a lab. What are the 2 main reasons for this? One reason never to bring food or drink into a lab is that you might accidentally contaminate your experiment. However, the most important reason is that dangerous chemicals in the lab can find their way into your food or drink. Good thing that's only a prop. Lab substances should never be tasted, touched, or smelled without permission. This is because unknown substances are potentially harmful. We want to be the scientists, not the experiment. Hands should always be washed after working with certain materials like soil or chemicals. After all, what's in the lab should stay in the lab. Are there any other safety measures that you think should be followed in a lab? Tess is trying to lift up the stage backdrop using this rope, but it's too heavy for her. Hey! Here's a chance to practice some scientific investigation. Scientific investigation always follows an organized plan or process called the scientific method. Here are the steps commonly followed in the scientific method. Can you identify Tess's problem? Tess's problem is that these backdrops are too heavy for her to lift directly using only a rope. From her research, Tess believes using a pulley system with 2 pulleys and 1 rope will decrease the amount of force required to lift the mass She needs to write this problem as a testable question. Testable questions make good problems for scientific investigation because they can be answered by setting up a test or an experiment. Tess predicts an answer to her question. This is Tess's hypothesis. Do you agree with this hypothesis? One thing to remember is that it doesn't matter if the hypothesis is right or wrong in the end. Right or wrong, we as scientists learn a lot from working through this process. Time to experiment. Tess is going to need a systematic approach. Not like Dr. Frankenstein, who's willy-nilly pouring potions and pushing buttons. Tess is first going to write down her procedure, step by step. This procedure also needs to include a list of materials that she's going to need for her experiment. Why is it important to document the steps of the experiment? Each step needs to be carefully documented so that Tess and others can repeat the experiment and prove her results to be true. Let's say that Dr. Frankenstein changed both the amount of electricity and the amount of liquid nitrogen that he gave to his monster creation. It's alive! But because he changed two things at once, Dr. Frankenstein has no idea which one was the magic ingredient. In scientific investigation, only the one factor that is being tested is allowed to change or vary during an experiment. This factor is called the independent variable. All other conditions must remain the same or remain constant during the experiment. With Tess's experiment, we're testing the force needed to lift each mass in two ways. What is Tess's independent variable? The independent variable being tested is the different ways in which the mass is lifted, with and without a pulley system. Before beginning her experiment, Tess draws up an observation table to record her data. This table will help Tess spot patterns that can help her form a conclusion later. Let's take a look at the data Tess has collected. How much did the amount of force decrease when Tess used the pulley system to lift the bucket of sand? The amount of force needed to lift the bucket of sand with the pulley system is half as much as the force needed without the pulley system. What does the data tell us about Tess's hypothesis? The data supports Tess's hypothesis. Now that she has analyzed the data, Tess is ready to write her conclusion based on the data. What is Tess's conclusion? Tess's conclusion is, based on the data, using a pulley system with two pulleys to lift a mass decreases the amount of force needed by half. Great job, Tess! Time to put everything back where it belongs so that these tools can be used again later. That's quite a bit of information about experimental investigations. Although the steps may vary slightly, observational investigations also follow a sequence of planned steps. As an example, let's pretend that earlier in his career, Dr. Frankenstein was investigating the effect of the full moon on werewolves. Dr. Frankenstein cannot control the moon or how the moon affects werewolves. To answer his questions, Dr. Frankenstein can only observe and draw conclusions from his investigation. This is an example of a make-believe, observational investigation. For a real-life example, let's join a team of climatologists. A climatologist is a scientist who investigates questions about climates. This team is currently observing this volcano in action. Look at that ash cloud. All this ash being spewed out into the atmosphere will block out sunlight for days. The problem the climatologists are currently working on is whether this ash cloud will affect the climate and life around the volcano. What is your hypothesis on how this will affect the climate and life around the volcano? The climatologists have hypothesized that temperatures will decrease because the ash cloud will most likely block sunlight for several days. Why would an experimental investigation be difficult in this situation? Variables such as the erupting volcano or the movement of the ash cloud cannot be controlled. This makes it difficult to conduct an experimental investigation. How then will the climatologists test their hypothesis? Instead of setting up an experiment to collect data, they will conduct an observational investigation. This investigation is mainly based on gathering data from observations. The climatologists will gather data such as these from various sources. These sources include satellite images and sensors placed on orbiting spacecraft. Then they will look for patterns and changes in patterns to see whether their hypothesis is supported by the data. Finally, they'll draw conclusions based on this observational data. In this case, we'll just have to wait and see what the data shows. It's almost showtime. Before we take our seats, let's go over what we learned today about safety and the scientific method. Today, we learned that scientific investigations may be experimental or observational. We also came up with some safety measures that should always be followed when performing any kind of lab investigation. Although the steps may be slightly different, we know that all scientific investigations follow a similar process to find answers to a specific problem. And that looks like all the time we have today because the play is about to begin. Break a leg, everyone!